Okay, so for this lecture, video lecture, will be talking about machine learning, percentiles, and also data distribution. So it will be two lessons for this particular video. So what are percentiles? Percentiles are used in statistics to give you a number that describes the value that a given percent of the values are lower than. So for example, let's say we have an array of the ages of all the people that lives in a street. So given here are the ages. So what is a 75 percentile? The answer is 43, meaning that 75% of the people are 43 or younger. So NumPy module has a method for finding the specified percentile. Again, 75% are younger than 43. Or 43 or younger. So use the NumPy percentile method to find the percentile. So in this example, we import the NumPy module. Then we have here the ages. And then x equals NumPy, the percentiles, ages, comma 75. So this is the percentile. So it will place here 43. Okay, so again, 75%, that means 75% of the people are 43 or younger. So here, what is the age that 90% of the people are younger than? So import NumPy ages, so the same with the previous one, but we use x equals NumPy that percentile ages 90, so that means 61. So 90% are younger than 61. So that's percentile. And let's now proceed with data distribution. So data distribution. Data distribution. Earlier in our tutorials or video lectures, we have worked with very small amounts of data in our examples, just to understand the different concepts. So these are used for concepts. Again, the data that we've been using are not real-world data. But in the real world, the data sets are much bigger, but it can be difficult to gather real-world data, at least at an early stage of a project. So especially that we're just trying to learn machine learning, then most of the data that we're using are just data just created by Python, or we just these are not real-world data. So how can we get big data sets? To create big data sets for testing, we use the Python module NumPy, which comes with a number of methods to create random data sets of any size. So here we have an example to create 250 random floats between 0 and 5. So how do we do that in Python? We just import NumPy, then we use this function or method. So x equals NumPy.random.uniform. So we have uniform distribution. So that means that more or less we have the same, almost the same for the distribution of these numbers. So 0, 5.0, 250. So print x. So these are the numbers generated. So that means this is the lower limit, the upper limit. That's why it's from 0 to 5. And this is the number of the random numbers that will be created by this method. So here we have 250 random numbers. Now we can draw a histogram. So to visualize the data, we can draw a histogram with the data that we collected. So we can use the Python module matplotlib to draw a histogram. So you should first install this one if you haven't installed this yet. Okay, so here we have now the first three lines are actually optional. You can just remove this one, or at least try to remove this, just in case it will not show in your computer. Then maybe you can try to import this one. So that will be shown on the next screen. Okay, so we have import NumPy, and then import matplotlib.pyplot as PLT, so just to shorten the name. Then first we created a random 250 random numbers or float from 0 to 5. So it's stored in X by using this method, just like what is shown in the previous diagram. And then we use this command plt.histogram. So histogram X, these are the numbers to be plotted, and then we have 5. So these are the 5 ones. So 0, 1, 2, 3, 4, 5. And then, or this will create rather 5 bars. So these are the 5 bars. And then plt.show. So this will now show this histogram. These are the range actually. So 0 to 5 will be the range. And the 5 here is the number of bars that will be created. You can experiment. Try to change that one. So Histogram Explained. We use the array of the examples above to draw the histogram with 5 bars. So I use 5. The first bar represents how many values in the array are between 0 and 1. So this one represents the number of arrays between 0 and 1, and then this is between 1 and 2, etc. Okay, so the second bar is between 1 and 2. So which gives this result, but just try to ignore this result because the array values are random. So the histogram shown on the previous slide is not necessarily the result shown in this slide. Or if you try this, it may be different with what is displayed on your computer. So additional note, as I've said last time, just in case this will not, the diagram will not appear, you can try this one. You install this, and then you can use this now in your code. So just like in the previous one. Okay, but first you ignore this. Try to ignore this one. If it is okay, it will the diagram will show, then no problem. We need not do this one. Now let's take a look at big data distribution. So an array containing 250 values is not necessarily very big, but now you know how to create a random set of values. And by changing the parameters, you can create data set as big as you want. So just like in this case, so instead of 250, we change this one to 100,000. So this will create 100,000 values. And in our diagram, instead of just 5 bars, we use 100 bars. That's why you notice if you're going to count the bars here, it's equivalent to 100 bars. Then we can have also what we call the normal data distribution. In the previous chapters or previous videos, we learned how to create a completely random array of a given size in between two given values, or actually in the previous slide. Okay, so in this slide now, we will learn how to create an array where the values are concentrated around a given value. In probability theory, this kind of data distribution is known as the normal data distribution or the Gaussian data distribution, after the mathematician Carl Friedrich Gauss, who came up with the formula of this data distribution. So the same, almost similar code, but this time around, so we import this one to plot our histogram, and then instead of uniform, we use normal. So this is what we just changed. So we have 100,000 numbers. So we have 100 bars. And then if we plot this will be our diagram. I think there's something wrong with this. This should be 10. I think this should be 5 to 10. So more or less, or this is the higher and lower limit. I think that's 5 to 10. So a normal distribution graph is also known as the bell curve because of its characteristic shape of a bell. So we use, yes, so that's really 1.0. So it's different with the uniform one, which is the limit, but here we use the deviation. So 1 as the deviation. So here's, in a way, it is explained here. Use the array from the NumPy random normal method with 100 values to draw a histogram with 100 bars, and we specify that the mean value is 5. So that's the mean. That's the average. That's why you notice here, that's the mean, that's the center. And the standard deviation is 1.0. So that means most of the values will deviate only by 1 with the mean. So meaning the values are concentrated around 5 and rarely farther away than 1.0. So again, most are within this range, 4 to 6. So meaning the value should be concentrated and at farther away from 1.0 or the mean. And as you can see from the histogram, most values are between 4 and 6 with the top at approximately 5.0, which is actually the mean. So that is actually the normal distribution. And thank you for viewing this video. So in this video, just a recap, we have learned how to create random numbers. So uniform distribution and normal distribution. As also we have learned in the previous on the first lesson about percentiles. So thank you very much for viewing this video.